Okay, I want to solve a U substitution problem, and I also want to talk about how the limits of integration are going to change. So let's look at this one. I found this in our textbook. It's the integral from 1 to 4 of e to the square root of x divided by square root of x dx. And at the moment, it might not be so clear what to let u equal, but I think a reasonable thing to try is to try letting u equal the square root of x. And if we try that, well, then the derivative of this is going to be 1 over 2 times the square root of x. And if we go through the process, we can solve for dx. Let's move that over to the right-hand side. And we get dx equals 2 times the square root of x times du. So I'm going to put this in a box here. And I'm also going to put u equals square root of x in a box, because those are going to be helpful formulas for us later. And let's just try. Let's sort of see what happens. So if we rewrite this, the main thing we want to do is we now get e to the u, because our square root of x was equal to u. And let's just rewrite everything for the moment. Now let's sub in using our formula for dx. So let's use that to substitute in here. So we're going to get the integral of e to the u times 2 square root of x du. And then we're dividing by square root of x. And finally, we get that lovely cancellation, which is good. So now we get the integral of 2 e to the u du, which is equal to e to the u times 2. And remember now that this is a definite integral. And definite integrals, the answer needs to be a number, not a function. And there are two ways that we can proceed. One way would be to rewrite everything in terms of x. And so let me kind of show you what that would look like. So that would be, for example, if I were to go here, maybe 2e to the square root of x, and then I would evaluate from x equals 1 to x equals 4. And if I do that, I'm going to get 2e to the square root of 4 minus 2e to the square root of 1, which is 2e squared minus 2e. And that will be my answer. Now, that's perfectly fine. And what we should do if we want to do that is we should kind of fill in our integrals and emphasize that really x is going from 1 to 4. And I would be really pedantic and include all of these indications here that really x is our variable and not u, because it's easy to make a mistake and get these things confused. And so let's see if we can get that answer by changing the bounds of integration in terms of u instead of x, and see if that's any different. So I'm going to go back some stages, just kind of erase everything we've got. And I want you to think about, and maybe even pause the video here, and say, if we know that x goes from 1 to 4, then what is u doing? Okay. And so, all right, we're back. So if x is going from x is going from 1 to x equals 4, then what do we know about u? Well, remember, u is equal to the square root of x. And so if x equals 1, well, that would mean u is the square root of 1. Well, that's 1. And if x is 4, then u would be the square root of 4, which is 2. And so what that should mean is that if x is going from 1 to 4, then u is going from 1 to 2. And so we can substitute that in here. U equals 1 to 2. U equals 1 to 2. 1 to 2. And now that since we're officially in the u universe here, where everything is in terms of u, I don't need to write the u equals anymore. And now when I plug in my answer, I get 2e squared minus 2 times e to the first power, which of course is the same answer we had before. So it's up to you which way you'd like to calculate these integrals. I think either of those is going to be fine. Also, as a bonus, let me solve one more problem for you. This came up on the Socrative that we did in class, and it was the integral of arctangent of x over 1 plus x squared. And I was very, very pleased that everyone sort of recognized that the correct substitution would be to let u equal the arctangent of x. And if you do that, then the derivative of arctangent is 1 over 1 plus x squared. And so we have this really nice expression here that says that du is just 1 over 1 plus x squared times dx. So what I'm actually going to do is I'm actually going to circle this expression here and show you that it really appears right in our integral up there. And so what I'm going to do straight away when I rewrite this is I'm going to say, well, this is the integral of arctangent of x, that's u. Maybe I'll put that in a different color. So green can be our arctangent function, so maybe I'll write this in green. And then everything else, that dx divided by 1 plus x squared, that's just going to become our du. In fact, maybe I'll make that red. And so the integral of u du is just going to be u squared, 1/2 u squared plus c. And to now get everything in terms of x, it's going to be 1/2 times the arctangent of x squared plus c. And I encourage you now to pause the video and double check that the derivative of this function is exactly what we got when we started. So thanks for tuning in. Have a great day.